Hello students, today we are going to learn about the calculation of reservoir capacity which is required for irrigation when the data of duty and required irrigation values are given. And please don't confuse this with the reservoir capacity calculation module 5 in which the sedimentation properties are used. Here we are going to calculate the reservoir capacity which is required for irrigation purposes, and it is included in the water resource engineering of Kerala Technological University. So let us see the first question here. Here the base period, intensity of irrigation and duty of various crops under a canal system are given below. And the reservoir, we have to find out the reservoir capacity is the canal losses are 20% and reservoir losses are 12%. So that means, look here, here for wheat the base period is 120 and duty at the field is 1800 and area under the crop is 4800. So we have to calculate for each crop we have to calculate the discharge required and volume of water required. Either you can do it like this in these steps, or we can continue this table like this and draw two more columns, one for discharge required and one for volume of water required. So for wheat we can see discharge required. Discharge required will be equal to area by duty. That is equal to, look here, if we number the columns like this, 1, 2, 3, 4, 5 and 6. So first discharge required is equal to, we said area by duty, that is area under wheat, that is 4800 by duty at the field, equal to 1800. So that is 4800 by 1800. So we can write that value here, this value, that is, let it be 48 by 80, that is after cancelling these zeros. And after that for wheat we have to calculate the volume of water required, that is, let us say here we said 48 by 18 cumex is required for irrigating wheat for the entire base period of 120 days. If so, we have to calculate the total amount of contained throughout this 120 days if this much discharge is provided. That is, how can we find that? This cumex means that is 48 by 18 meter cube per second. So multiply it with the time period, you will get the volume, that is 48 by 18 into 120 days it is. So if we multiply it by 120, we will get the unit as, look at here, this is a calculation, into 120, that you will get it as 320 cubic days. That's the same unit as 320. If 320 cumex is provided for, sorry, not 320, 48 by 18 cumex is provided for 120 days, this much volume of water will be present. So we got the volume of water required as 320 cubic days, and 1 cubic day means it is the volume of water you will be getting if we provide 1 cubic for an entire day, that is equal to 1 into 1. If we convert that to meter cube, it will be 1 into, that is 24 hours into 60 into 60 seconds, that is, this is 1 meter cube per second into, you convert 1 day into seconds, that is 24 hours into 60 into 60. 2 seconds cancelled, and you will be getting the value as 24 into 60 into 60 meter cube. That is the volume of water if we denote it as 1 day. Okay, so here we got 320 cubic days. That is right here, 320. Okay, now that is the volume of water required for wheat. Now for sugarcane, do the same calculation. That is area under the crop. Sugarcane is 5,600 and duty at the field is 800. Therefore, 5,600 by 800. So this column you will be obtaining by dividing fourth column by third column. 5 is equal. So here 5,600 by 800, that is equal to 7 cubic is required, and volume of water required is equal to 7 into, here the base period is 360. Therefore, you will be getting it as 2520 cubic days. So similarly, you have to calculate for cotton, then for rice and vegetables. These two are, we will be calculating it now. So when you do the problem, maybe you should calculate it and write the values in this table here also, so that the calculation will be easy. Because finally you have to take the total of these values you obtained here for volume of water required. So after doing the calculation for rice, here discharge required is, area under rice is 3,200 by duty 900, and volume is equal to this value multiplied by base period of rice for 27 cubic days. And for vegetables, discharge required is equal to 1,400, where 1,400 is area under vegetables and 700 is duty, hence 2 cubic is required. Now volume of water required is equal to 2 into 120, where 120 is the base period of vegetables, and you will be getting it as 240 cubic days. Now, what we need to do is we have to sum up all the total volumes, all the volume of water required for each crop. 320 plus 320 is for wheat, 2520 is for sugarcane, 343 is for rice, then 427 is for rice, and 240 is for vegetables, and there's one in between. Anyway, we had 5 crops, and 343 was for cotton. So total you will be requiring this much volume of water, that is 3850 cubic days. So we can convert it into meter cube by multiplying this 3850 with 1, that is 1 meter cube per second into 24 hours into 60 minutes into 60 seconds. So you will be getting the value as, okay, here we are going to, what we need to do is first we have to convert this 3850 into meter cube, that is equal to into 24 into 60 into 60, and this much volume of water is required, that is represented in meter cube. Okay, now we have to convert this into hectare meter. Now hectare meter is another unit of volume, which is 1 hectare is equal to 10 raised to 4 meter square into meter, that is equal to 10 raised to 4 meter cube is 1 hectare meter. So you have to convert this value to hectare meter. For that we can divide this value by hectare meter, that is 3850 into 24 into 60 into 60 by 10 raised to 4. If we do that, you will be getting the value as 33264, that's equal to 33264 hectare meters. That is, in irrigation engineering you will be usually representing the volume in hectare meters, and we usually represent discharge by cumex sorry, okay, discharged by cumex, and sometimes the volume is also represented in cubic days. So this much is the volume required on the field. Okay, let us see what we did here. First we calculated all the discharge required and volume of water required for each crop. Then we added up the total volume of water required on the field for all crops. We got it as 3850 cubic days. Then we converted this cubic day into meter cube, that is by multiplying 3850 with 24 into 60 into 60. Then after that we converted that value into hectometers, that is by dividing the value by 10 raised to 4. That is, first we did 24 into 60 into 60 divided by 10 raised to 4. That is, here 1 cubic day equal to 24 into 60 into meter cube divided by 1 hectare meter, that's equal to 10 raised to 4 meter. You will be getting it as 8.64 hectare meter. That means 1 cubic day is equal to 8.64 hectare meter. Therefore, multiplying 3850 by 8.64 will give you the total volume of water required in hectare meters. We have calculated the total volume required on the field as 33,264 hectometers, and also in the question we have the canal losses as 20%. That means, let us see, this is a reservoir and here there is a dam and this is a canal system. Okay, there are certain branch canals, and then finally here we have our field. Okay. So what we found out here is total volume required on the field is a water that we require here, that is 3,264 hectare meter. For that, now in the question the canal losses are given as 20%. That means during conveyance from here to here the losses will be 20%. That means we have to provide an amount of water here such that after 20% loss you will be getting this value. That means let this value be uh, let it be x. Okay, so what we need here, 20% will be gone as losses. That means how can we obtain this value, or how can we obtain this value? Okay, we need to find out how much water is first. Finally we have to find out the reservoir capacity, that is water that should be present here. But when we supply water from here, there is a loss of 20%. That means x minus 20% of x, that is equal to 33264. That means x minus 0.2x equal to 33264. That means x is equal to 33,264 by 0.8. That is what we have done here. 33,264 divided by 0.8. So you will be getting the value of x, or the water that should be provided here or opened from the reservoir, that is equal to 41,580 hectare should be diverted or released from the reservoir, so that you will be getting this much, that is 33,264 hectare meters in the field. Okay. So we have accommodated the canal losses. Next, we have to accommodate the reservoir losses. That is, reservoir losses is given as 12%. That is, reservoir losses means that will be the water lost due to evaporation, then percolation, etc. So We need 41580 hectometers here. We have to provide a volume of water Y in the reservoir. That means after losses from Y, that is after 12% losses from Y, you need this value. That means, let us say, Y minus 12% of Y is equal to 41580. That is equal to 0.88. Y is equal to 41580. Y is equal to 41580 divided by 0.88. That is equal to 47250. So that is what we have done here. Hence, water required in the reservoir or gross reservoir capacity is equal to water to be released, that is, or water required at the head of the canal. It means head of the canal or canal system is this point. So water required at the head of the canal, we found out it as 41580 divided by 0.88 will give you the total reservoir capacity required. That is equal to 47250. Final answer. Or this much water is required in the reservoir, so that after reservoir losses and conveyance losses, you will be getting this much water in the field. This much water in the field. That is now this question is complete. Let us move on to the next question or a similar question. See, here it is the same question only. You can either do it as homework or okay, I will explain it. Now the question: determine the reservoir capacity if culturable command area is 5200 hectares, canal losses are 20% and reservoir losses are 15%. Okay, let us see. The question: four crops are given: wheat, sugarcane, cotton, and rice. Each of its base period are given. Then duty at the field is also given, and intensity of irrigation is given. Earlier, directly the area under each crop was given. Here, intensity of irrigation is given. So, from intensity of irrigation, you can find out the area under crop. That is 20% of 5200. And areas 20% of CCA is the area under wheat. Then 20% of CCA is the area under sugarcane. Then 10% of CCA is area under cotton, and 15% of rice CCA is area under rice. And those values are obtained here. Now from that you can find out the delta. Your duty and base period are given. We can find out the delta. This is another method of doing the same problem. So delta, we know delta is equal to 8.64 B by D by your equation. Okay. So 8.64 B by D, by doing that 8.64 B is in the column number 2 and D is in the column number 3. Here it is 8.64 into by 3. That 8.64 into 2, that is for wheat 8.64 into B is 120 by 1700, you will get delta as 0.609. Similarly for sugarcane you will be obtaining it is 1.97 and cotton 1.296 and for rice it is 1.48. From that, so this is the height of water required. So to find out the volume of water, you have to multiply the area under the crop into the height of water. That is this much area in hectare multiplied by this much height of water in meters. So volume of water required is equal to column 5 into column 6. So this is 5 and this is 6. So 5 multiplied by 6 will give you the total volume of water in hectare meters. So for wheat, total volume of water required is 1040 multiplied by 0.609, that is equal to 633. Similarly for sugarcane it is 1040 multiplied by 1.97, that is 248. And similarly you have to find out it for cotton and rice. Now we got individual volume of water required for each crop. From that you can find out the total. So total of this is 4509 hectometers. That is total volume is 4509 hectometers. So now we have to incorporate the reservoir losses and canal losses and reservoir losses. So what we in a similar manner that we did in the previous question, we are going to find out the water required in the reservoir, and this is a dam, and this is a canal system. We have many branches like this, and finally this is our field. Okay. Water required here is 4509 hectometer, and canal losses, that is conveyance losses, are given us 20%. So head required at this point, that is the volume of water required at the head of the canal, is equal to volume required at head of the canal is equal to 4509 hectometer, which is equal to 45.009 into 10 raised to 6 meter cube. Okay. So 45.09 into 10 raised to 6 meter cube is the water required here. So to find out the water required here, we have to divide that value divided by, that is 45.09 into 10 raised to 6 divided by, here it is, reservoir loss at 20%. So in a similar manner that we did in the previous problem, you can take it as 45.09 into 10 raised to 6 divided by 1 minus 0.2, that's equal to 0.8. So 45.09 raised to 6 divided by 0.8 will give you the value of water required at the head of the canal as 56.36 into 10 raised to 6. That is water required here is 56.36 into 10 raised to 6 meter cube. So that is water required at the head of the canal. That is to be opened from the reservoir. Now there is reservoir loss of 15%. To get that, we have to divide this value by 1 minus 0.15, that is 0.85. That is water required at the reservoir or storage capacity is equal to 56.36 into 10 raised to 6 divided by 0.85, and you will be getting the value as 56.3 into 10 raised to 6. So that is our final answer. This is the final answer. Now, look here. This problem is a previous year university question. It has come up in, I think, the 2 years before. In 2019, the university exam of 2019, I think. Anyway, 19 or 18 anyway. So this question is a previous year university exam question which had a mark of 6 mark, and you can see the mark distribution. This is after finding, if you found out up to the total volume, you'll be getting 4 marks, and if you find out the volume required at the head of the canal, you will be getting 1 more mark, and if you find out the storage capacity, you will get getting 1 more mark. So that is a mark division. So I hope you understand these two problems.